Welcome to Energy Talks, a regular podcast series with expert discussions on topics related to power system testing, data management, and cybersecurity in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. In this episode, we will examine how to measure the efficiency of protection relay testing. Protection relays and protection test sets have changed significantly over the last decades. While relays transitioned from electrical mechanical devices to digital ones, test sets have been developed to meet new demands. Nonetheless, they are often used in the same way as previously during pre-digital times. But nowadays, digital relays offer many more settings and parameters. Testing them with old, especially manual approaches, is very inefficient. This becomes even more tangible if put into numbers. But to compare the efficiency of different testing approaches, we must discuss what can and should be measured. Michael Albert, an OMICRON expert in test automation, joins me for this discussion. He was a guest on Energy Talks episode number 36 about protection testing. This time, Michael will discuss the increasing importance of protection testing efficiency and how it can be measured. Hi, Michael. Welcome back to Energy Talks.
Thanks, Scott. Thank you for asking me again to come to Energy Talks. How are you doing?
Great. Thank you so much again for being here to talk about protection testing efficiency and how it can be measured. Michael, why are effectivity and efficiency so important nowadays in protection testing?
The need for electricity is growing day by day, so in every country in the world. And also the energy transition makes it quite important to invest a lot of money in the electrical grid. And if you change the grid, if you change the assets in the grid, you have to test the protection in this field and the protection devices. And therefore, we have a growing testing demand. And at the end of the day, the development in the last years, also the IEDs itself, so the protection relays itself, are getting more and more complex. And therefore, you have the same people, perhaps you have less people working in the field, so you have to be more effective and more efficient in the work you have to do every day.
So you said that protection relays became more complex. Can you go a little bit more into detail?
This is quite interesting. If we go back perhaps 30, 40 years, so we have a few settings in the protection device. So let's say 20 or 30, and the idea was going to the substation and test every parameter in this device. So, and if we look at the protection devices nowadays, so we have several hundred of parameters. And it's at the moment, it's impossible to test every parameter in such a device in the substation. And therefore, you have to take this into consideration if you go for more testing.
Okay, so what does this mean for day-to-day work of protection testers in the field?
They have to overwork what they are doing. So at the moment, it's not possible, just as I said before, it's not possible to test everything like 40 years ago. And therefore, the protection tester in the field have to master all these new things. So more parameters, more functions in the devices, and perhaps more complicated functions. It depends on the protection device, on the asset. So therefore, it might be more complex functions also available, and therefore they have more different things to do than years ago.
Okay, so even with clear instructions, these extra parameters that need to be tested, how can you test so many parameters?
So as I said before, it's not possible to test every parameter. So that makes no sense, but you have to test more parameters, a lot more than before. And the key is standardization. You have to standardize your testing procedures, and you have to be clear what are you going to test and how you are going to test it. And then you can go to the substation, you can put your test equipment, and the final step, if you're good at the what and then the how, then you can go for perhaps a final optimization, just using test automation. So that makes it much more efficient than before. So they have to choose the right tool in the end.
Okay. The two terms, effectivity and efficiency, are quite often mixed up. Can you explain to us the difference between them and give us an example?
Yeah, sure I can. So let's start with effectivity. So effectivity, there's some easy definition of it, doing the right things. So that means if you go in the substation for a test, you have to know what to do. That this is defining the what. And efficiency, that's doing the right things correctly. So you're sure about the how. And of course, you're choosing the right tool. Perhaps I give you a different example, just a little bit off topic of electricity. So if you're going to tighten a screw, for example, you have only to tighten one screw, then you will choose this screwdriver, of course, and you say, okay, this is fine. It's effective because you know what to do, you know what you are doing. But if you go for 100 screws, today you will go with a portable electric drill and you say, and everything is fine. Then you are efficient.
Okay. Michael, one aspect is the quality of a test. What defines test quality? Can you tell us a little bit more about that?
Yes, I can. And the quality of the test defines it's an important property of a test. So it can be different from the test purposes if you're going for a FRT or a routine test or a type test. So for example, if you go for the repeatability of a test, this is a quality. So it's a little bit more important if you go for a type test than for a routine test. But if it's, for example, the test coverage, it might be very important in the FAT test because this is a factory acceptance test where it's very important to have everything tested because it's the first time where you check everything for your substation. So this is important to know that it's not the same qualities for every test. So it depends on the purpose. So it can be, as I said, repeatability of a test, the performance of a test, or the test coverage. Depends what you're going to do.
Okay, let's go into a little bit more detail about what is needed to measure the quality and efficiency of a test procedure.
Yeah, so in the end, we need some kind of KPIs. So we need key performance indicators just to check and to have something to know how to measure it and what we are measure to say this is an important thing. So for example, test coverage. Test coverage means in this context that we have to test 20 parameters or 100 parameters, and we have to know at the end, are all these parameters tested? So if we just have 50 parameters, which can be changed from feeder to feeder, then if we test 50 parameters, then it's the test coverage 100%. And if it's less than 50 parameters, it might be okay, but then we have a test coverage of 90% or less, for example. So this can be measured, and we can say, okay, these tests are done with a KPI of 0.8, 0.9, whatever. And also we can do this with other qualities like performance of a test or efficiency of test. It depends what we want to know.
Okay, so how can you measure the efficiency of a test procedure exactly?
So efficiency in general is related to the time you need to do the work. So this is quite clear. And in the end, we have to measure the time for the completion of the test. And if we measure the time, we need to include the preparation of the test, the execution of the test, and in the end, the reporting and documentation of the test too. This is the thing we have to do here.
Is there an indication of how much time and effort is needed to test protection relays in a substation using state-of-the-art approaches?
It's difficult to say 10 minutes, it's needed an hour, it's needed 5 hours, because it's the same thing like before. The testing purpose is very important to say that's good or not. And in the end, if you go for a test for distance protection, for example, for distance protection in the substation, you say, I need 4 hours, then you cannot compare it. So if we do the work measuring the time for the whole testing process here, we need to have a reference. And without a reference, it's not possible. And the reference, now we come back to the screwdriver example at the beginning, is just to say how we do it, or how we have done it yesterday or 20 years ago. Then we can say, okay, we need for testing the device a day and using the right tools at the moment, or the right tool, the state-of-the-art approaches today, we need 2 hours. And then we can say we save 50%, 80% of the time. This is what we have to do. So we have to have a reference.
So given that, can you give us a practical example?
I can try it. It's a little bit complicated because now we need some pictures or whatever. It would be nice, but I try to describe it a little bit. Just imagine we have to prepare a test plan. So the preparation time is, for example, 1 hour. So we have to prepare 10 test steps, and all these test steps have to enter manually. not just 1 hour. And in the end, we have to execute the test, it takes another hour, and we have the documentation, it takes another hour. So we have 3 hours. That's a manual approach. There's a need just to have 3 hours for the whole process. And this will happen again and again. So we have these 3 hours for every relay we test. So this is the reference. And if we now just using state-of-the-art tools, we will have a preparation time. For the first time, perhaps a little bit more because we want to have this test plan automated later on. That's going the next preparation time, it will be faster. So let's say we have the double or three, perhaps 3 hours, a little bit more, or 4 hours, whatever. So we need more time for the preparation for the first device. The execution will be faster because there's no manual interaction during the test. And the documentation will also be in no time because the documentation is also automated. That means 4 hours preparation, perhaps 20 minutes, 10 minutes for execution and 0 minutes for the documentation. So in the end, first time we are a little bit slower than with the manual way, but now we have to expand this to 20 relays, 30 relays, 50 relays with the same kind of devices where only a few parameters are changed. So that means for the second one, the preparation time of the manual test is still 1 hour. For the automated test will be 5 minutes because we have, of course, to enter the settings, but then everything is fine. So that means with the second one, we will gain the time back. And in the end, after at least the third one, the fourth one, and now this depends on the testing purpose and the complexity of the test, of course, then it pays back and it will be more efficient later.
Very good. So the more you do the testing, the quicker it will be the next time and the time after that.
Exactly. So it's normal that you have in a substation, you have a few feeders which are quite the same. They have quite the same settings, not exactly the same, but only vary in 20 parameters, which can be entered very quickly. But the test functions, it's completely the same. So that means there's a payback here in the substation. And this is for every substation.
Very good. So what does this mean in terms of costs, or rather savings?
Yeah, in the end, it's a little bit of an investment at the beginning. As I said, the first preparation needs more time, but it's all investments which are done in a good way. It will pay back very quickly. So I would say efficiency, if you save working time, you will save money because you can do more things in the same time. So that means start directly, checking, measuring the efficiency of the testing approaches. So that's what I can recommend at this point.
Changing an established test approach isn't that easy. As you mentioned, in the beginning, it requires preparation and get everything set up to be able to do the tests efficiently. What are some of the other first steps that you should consider? What would you recommend?
So the first thing is that you say that you're willing to do it, so that you're willing to change. The second is that you have to be aware that there are people involved. So people are doing the work for years and they are used to do it in their way. And if we want to change something, they will say, okay, why I have to change? Have I done something wrong the last years? Why? So it's change management. So we have to involve the people at the beginning. And the second point is that we should not focus only on the testing. And so we have the example here. It's just the testing in the substation or the testing in the lab. So we have to check the whole process because we're doing automated testing, and what we have done in the FAT, a lot of these things have also been done in the routine test. Some things of the type test have to be done in the FAT. So you can hand over test procedures if we go for the whole process. So the efficiency or saving time and costs can be bigger than only focusing on one point in the testing process.
Now, Michael, you've been with OMICRON in the area of protection testing for many years. How does OMICRON support customers with protection testing?
As you said, I'm with OMICRON a lot of years now, and I have experience in the field of protection testing and the workflow optimization. But we are sharing our knowledge in that field. So that means we are able to help you with these questions. So we also have some knowledge in the field of transitional digital substation, where the IC61850 things are going to be realized in the substation, data workflow optimization, and of course we are able to help with the cybersecurity requirements in the substations, which will become more and more important in these days.
Michael, thank you for sharing your knowledge and experiences with efficient protection testing and how to measure it in this episode of Energy Talks.
Yeah, thank you very much that I could be with you in this episode. And if there are some questions just for the audience, just contact OMICRON and we are going to help you. Thank you very much.
Very good. Thank you again.
And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing, data management, and cybersecurity in the power industry, and offers you the matching solution for your application. For more information, be sure to visit our website at OMICRONenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.